Welcome to Episode 5 on Vision and Multimodal AI. This is Domain 3 of the exam, worth 10 to 15% of your score. It is a shorter domain, but it contains one of the most important exam traps in the course: the difference between Azure AI document intelligence and content understanding. In this episode, we cover the complete Azure AI Vision service, including Image Analysis 4.0, the Read API for OCR, Face API for facial recognition, Custom Vision for training your own models, Video Indexer for video content, and how GPT-4o's multimodal capabilities change what is possible with vision tasks. Let us start with the foundational service. Azure. AI Vision is the unified service for computer vision tasks on Azure. A single cognitive services account can access multiple vision capabilities through one endpoint. Image Analysis 4.0 is the current generation of the service and includes several capabilities. Captions generates a natural language description of the entire image. For example, a person sitting at a desk looking at a laptop. Dense Captions extends this to describe specific regions within the image, useful for detailed accessibility descriptions. Object Detection finds and locates objects with bounding boxes around them, returning the object name and a bounding box with coordinates. Tagging returns a list of descriptive keywords with confidence scores, good for categorizing large image collections. People Detection identifies the location of people in an image, but importantly, it does not perform face recognition. Smart Crops suggests optimal crop regions for different aspect ratios, useful for automatically creating thumbnails. For the exam, know that Image Analysis 4.0 handles general visual understanding, while the Face API handles identity-specific facial analysis. These are separate features with different capabilities and different privacy considerations. The Read API is Azure's OCR engine for extracting text from images and documents. It handles both printed and handwritten text and supports an extensive list of languages. The Read API is asynchronous for large documents. You submit the image and receive a URL for the operation. You then poll that URL until the status changes to succeeded. The response includes the text organized into lines and words with bounding box coordinates for each element. This is important to understand. The Read API returns the raw text and its location in the image, but it does not understand what that text means in the context of a form or document. For that structured understanding, you need document intelligence. Here is the key distinction for the exam. If a question asks you to extract text from an image of a sign or a photo of a whiteboard, the answer is Read API or Image Analysis with OCR. If a question asks you to extract the total amount from an invoice or the name from an identity document, the answer is Document Intelligence. The OCR capability in Image Analysis 4.0 uses the same Read API engine under the hood. The Face API provides facial analysis capabilities ranging from simple detection to full identity recognition. Face detection simply finds faces in an image and returns their bounding box locations. It also provides attributes like estimated age, emotion, happy, sad, angry, head pose, and whether the person is wearing glasses or a mask. Facial recognition features, specifically identification and verification, are limited access features in Azure. This means you must apply to Microsoft and receive approval before you can use them. This restriction exists for responsible AI reasons. Microsoft limits facial recognition to prevent misuse for surveillance, discriminatory profiling, or tracking people without consent. For the exam, face detection, finding a face in an image, is freely available. Face identification and verification, who is this person, requires limited access approval. The liveness detection feature verifies that a face is a real, live person, rather than a photograph, mask, or video playback. This is important for identity verification workflows to prevent spoofing attacks. Custom Vision is the easiest way to build your own image classification and object detection models without writing machine learning code. There are two model types. Image classification answers the question, what is in this image? For example, classifying product images as defective or acceptable, or categorizing wildlife photos by species. Object detection answers, where is each thing in this image? It returns bounding boxes with labels, useful for counting items on a shelf or locating defects in a manufactured part. The training process starts with uploading and tagging your training images. Custom Vision can train with as few as 15 images per class, though more images always improve accuracy. After training, the evaluation screen shows you precision and recall per class and the overall mean average precision score. For deployment, you publish the trained model to a custom vision prediction endpoint and call it via a simple HTTP API. An important export feature: you can export your trained model to ONNX, TensorFlow, or CoreML format to run it locally on a device, embedded in an app, or inside a Docker container with no internet connection required. Video Indexer is Azure's AI service for extracting rich metadata from video and audio files. Unlike the basic image analysis service which analyzes single images, Video Indexer processes the full temporal dimension of video content. The capabilities it extracts are impressive. It transcribes speech to text with speaker diarization, meaning it identifies who is speaking when. It extracts named entities, people, places, and brand names mentioned in the spoken content or visible on screen. It identifies key frames that represent each scene in the video. It infers topics from the dialogue and extracts sentiment per video segment. Visual labels identify objects and environments visible in each frame. OCR reads text that appears on screen, like slide content in a recorded presentation. All of this metadata is output as a structured JSON file and is fully searchable through the Video Indexer portal. For exam scenarios, if a question asks about analyzing a large library of recorded meetings, training videos, or news footage for insights, Video Indexer is the answer. If a question asks about analyzing a single image or document, use image analysis or document intelligence. Here's the exam trap that appears in Domain 3, document intelligence versus content understanding. These are two different services, and the exam will present scenarios asking you to choose between them. Document intelligence, formerly called Form Recognizer, is specialized for extracting structured data from forms and documents. It understands the layout of a document and can extract specific fields by name. If you need to extract the total amount, due date, and vendor name from an invoice, document intelligence is the answer. It has pre-built models for common document types: invoices, receipts, identity documents, business cards, tax forms, and more. You can also train custom models for your own form types. Content understanding is a newer service for analyzing multimodal content. Instead of extracting specific named fields, it performs semantic analysis, understanding the meaning, context, and narrative of video, audio, and complex visual content. Use content. Understanding when you need to analyze what is happening in a video, understand the context of a mixed media document, or extract insights that go beyond field-level data. For the exam, structured field extraction from forms equals document intelligence. Semantic analysis of multimodal content equals content understanding. GPT-4o is a natively multimodal model, meaning it processes images and text together in a single model call without needing a separate Vision API. You include images in the messages array alongside text. The model can describe what it sees, answer questions about the image, read and understand text within images with contextual comprehension, interpret charts and diagrams, and even compare multiple images in one prompt. The key differentiator from dedicated vision services is reasoning. GPT-4o can combine visual understanding with complex reasoning. For example, you can show it a chart and ask it to identify the trend, calculate the percentage change, and suggest what business decision the chart implies. That kind of multi-step reasoning combined with vision is unique to GPT-4o. For the exam, choose the right tool for the task. GPT-4o Vision is best for complex reasoning about images or understanding context and narrative. Azure AI Vision dedicated services are better for high-volume, real-time tasks like processing thousands of product images per minute. Document intelligence remains the choice for structured field extraction from forms. Custom Vision is for training your own specialized classifiers. Let us cement the vision domain exam traps. Trap 1 is the biggest. Document intelligence versus content understanding. Document intelligence is for extracting named fields from structured forms like invoices and receipts. Content understanding is for semantic, contextual analysis of multimodal content, including video. If you see a scenario about extracting line items from purchase orders, document intelligence wins. If you see a scenario about understanding what happened in a meeting recording, content understanding wins. Trap 2. Face API identification requires limited access approval from Microsoft. If you build an application that identifies specific people from a database, you must apply for and receive approval. You cannot just enable it. Trap 3. Read API versus document intelligence. The Read API gives you raw text, words, lines, and bounding boxes. Document intelligence gives you meaning, field names, values, and their relationship. Trap Chapter 4, Custom Vision versus GPT-4o. For classifying thousands of product photos per minute with a custom model trained on your data, Custom Vision is more appropriate and cost-effective. GPT-4o Vision is for tasks requiring reasoning, interpretation, and understanding context. Spatial analysis is a specialized capability within Azure AI Vision that uses video camera feeds to analyze people movement in physical spaces. It can count people entering and leaving a zone, detect when queues form, measure how long people dwell in a specific area, and detect when social distancing rules are violated. Like Face API identification, spatial analysis is a limited access feature because of its potential for surveillance misuse. Responsible AI for vision services comes up on the exam in scenario questions. The key principle: inform users when AI is analyzing images or video of them. If you are deploying a facial recognition system in a public space, you need to notify people and obtain consent where required by law. The Microsoft Transparency Notes are published documents for each sensitive AI service that describe the capabilities, limitations, and responsible deployment guidelines. The exam may ask which document describes responsible use guidelines for a specific AI service. The answer is the Microsoft Transparency Note for that service. For the exam, any scenario describing vision AI being applied to individuals without their knowledge would violate the responsible AI principles of transparency, fairness, and inclusiveness. Episode 5 Summary. Image Analysis 4.0 handles general visual understanding, captions, object detection, tagging, and smart crops. The Read API extracts raw text from images with bounding boxes, supporting 164 languages. Face API detection is freely available. Identification and verification require limited access approval. Custom Vision lets you train your own image classification and object detection models without writing machine learning code. Video Indexer extracts transcriptions, named entities, topics, sentiments, and visual labels from video. The most critical exam trap from this episode: document intelligence versus content understanding. Document intelligence extracts structured, named fields from forms like invoices and identity documents. Content understanding performs semantic analysis of multimodal content, including video and audio. They are different services for different use cases. GPT-4o Vision adds reasoning capability to visual understanding, but is not the right choice for high-volume production pipelines where dedicated vision services are more cost-effective. In Episode 6, we cover Language and Speech AI Domain 4. This includes conversational language understanding, named entity recognition, sentiment analysis, speech-to-text, text-to-speech, and translation.